Hello bachcho. In the last lecture of thermodynamics, we have studied about the basic concepts of thermodynamics, that is system, surroundings, boundary, types of systems, what is process, types of processes. That too based on some criteria, based on nature of process, based on condition of process, based on execution. Based on condition, we have studied the isothermal, isochoric, isobaric, adiabatic. And based on nature, we have studied the expansion compression process, physical change, that is phase change, and chemical reaction, that is chemical change. Okay, then next, based on execution, I have only taken name. That explanation will be provided afterwards, that is reversible and irreversible. Today we will study about the properties of matter, properties of system. Okay, properties are of two types. One is intensive properties, another is extensive properties. Okay, what are intensive properties and extensive properties? The properties are classified into two types. One type is extensive. Extensive means those properties which depend on the amount of substance taken in the system. That is, if you change the matter, the amount of matter present in the system, those properties will change. Example, volume and internal energy. They will change according to the amount of matter. What is internal energy? You will study afterwards. Volume, you know. If you take some 10 gram of water can be measured in terms of liter also, gram also. If you take 10 gram of water, then some volume it will occupy. Okay, if you change the amount of water, then the volume will also change. Like that, it will depend on the amount of substance taken. It is called as extensive properties. And the properties which are not extensive or intensive. Okay, means they will not depend on the amount of substance taken. For example, temperature. Now if you keep any water at some temperature, say 50 degree, now remove some water, again it will be 50 degree only, no, because the temperature will not change according to the amount of substance. Okay, temperature, pressure and all are intensive properties. Okay, intensive properties, difference. Okay, they do not depend, upon amount of substance taken. Okay, these depend on amount of substance taken, substance taken in the system. Okay, okay, these examples are volume, then internal energy, etc. Here pressure, temperature, etc. And remember, all concentration terms you have studied in first chapter, no, molarity, molality, normality, those are all concentration terms are intensive properties. Because if you consider molarity, then the number of moles of solute by per volume, 1 liter of solution. Okay, then if you divide the number of moles by volume of solution, it will become intensive. How means, if how much amount also you take, but number of moles per liter will be same, no, it will be constant. So molarity is the intensive properties, means number of moles are extensive properties, volume is extensive property. If you divide extensive by extensive, you will get intensive. It is also another point. If you divide extensive by extensive, you will get intensive property. For example, molarity. Okay, now molar mass. Molar mass is also intensive property, gram per mole. Okay, if you take 10 moles of some any substance, any element, then its mass may vary with your moles. If you take 9 moles, the mass is different, 10 moles, the mass is different, but the mass per mole is same, no, that is called as molar mass. It is an intensive property. Okay, and extensive properties are additive, means in physics you talk about scalar and vector, no, scalars, they will be added like numbers 1 plus 2 plus 3, like that, scalar addition. This follows scalar addition. In terms of physics, I can say like that, or you can say that simply this extensive properties are additive. Okay, but intensive properties are not additive. Extensive properties are additive. These are not additive. Okay, आपको मतलब समझ में आया ना? What is intensive and what is extensive? Okay, in exam they will ask questions on this. Okay, JEE and NEET, they will ask, they will give some properties like volume, pressure, internal energy, enthalpy, entropy, and they will ask you whether it is intensive property or extensive property. I will tell a concept or a trick. You can take as a trick or as a concept. All will teach. All physical chemistry teachers will teach you. You may take that as a concept. Okay. Now, if they ask any property, if they take any property, okay, I will only ask you whether volume is an intensive property or extensive property. If I ask you, you may forget or something in exam. Okay, temperature, pressure. Okay, how to do those questions? Okay, you assume a room. Okay, of some volume, volume V, temperature T, pressure P. Okay, you divide that room into two equal halves. Okay, now if volume divides, if the property divides, if any property you take, when you divide the room, if the properties divide, or in simple words, you build wall inside the room, at middle of the room, split into two halves. Okay, if the property change, if the property become half, then it is extensive property, because it depends upon the amount of substance taken. Here full room is taken, here only half room is taken. No, it will change, so it is extensive property. And the properties which does not change according to your division, those are called as intensive property. Now consider volume. Volume will change. If you take V of whole room, if you divide, then here will be V by 2, here will be V by 2. It is an extensive property. Okay. Now temperature. Temperature will not change. If 50 degrees Celsius is there, if you divide that room into two equal hours, here also 50 degree will be only there, T only will be there, here also T will be only there. Okay. It is intensive. Pressure also same. It will not divide. It is also intensive. This is a simple concept to remember whether it is intensive or extensive. If you can note, you can note down. Otherwise, leave. Now we will discuss about functions. Functions means state functions and path functions. There are two types of functions: state functions and path functions. What are those? We will discuss. Okay. First we will discuss about state functions. Okay. What is state function? State function is a function which defines the state of the system. Okay. Function which defines state of the system is called state function. Okay. For example, volume, temperature, those are state functions. They define the physical state or chemical state of the system, how it is solid or otherwise liquid, at how much temperature it is there, they define. No, so that's why they are called as state function. Okay. State function change, the value of state function changes, state of the system changes if value of state function changes. If you change the value of state functions, then the state of the system may change. Okay. You can say like this: state of the system is depends on the value of state function. Okay. Change in state function during any process does not depend on path followed by the system. Okay. Now this is the main important for the understanding of state function and path function, this point. Okay. State function, they do not depend on the path. Means for example, means how to explain that? See here. If any process happens, now boiling happens, now you will change the temperature of water from 0 to 100 degree. Okay, the temperature is changed from 0 to 100 degree. How it is changed? It will not depend on it. If initial temperature is 0 degrees Celsius and final temperature is 100 degrees Celsius, you consider the process boiling. Okay, there. Now if they ask change in temperature, that is delta T, what you will do? Direct T final minus T initial means what path it has followed, it doesn't matter. Only what matters is the final state of the system and initial state of the system matters for this change of state function. Okay, there are those functions which do not depend on the path followed by the system. Those are called as state functions. Okay. For example, volume, temperature and all, those are state function. You remember only two are there which are path functions, heat and work. ये दो छोड़ के कोई भी आया हो उसको आप स्टेट फंक्शन मान के चलना. ओके, नाउ चेंज इन स्टेट फंक्शन यू कैन डिफाइन लाइक दिस. Take phi, some phi as state function. Okay. Now consider a small change. Okay, a small change in state function. This phi as d phi. Okay, if you want, if an object is at initial state 1, and it has changed it to state 2. This is the final state. Okay, you consider like this. Then what is the value of change of this state function? You take small change d phi and you integrate from state 1 to state 2. If you integrate, you will get final change, total change of this state function phi. Okay, that formula is phi at state 2, final value of the state function minus initial value of state function. If you do it, you will get the total change in this state function. Okay, this is the formula for state function. Okay, clear? Okay. Now for cyclic process, the total change in the value of state function remains 0. Okay, the state function, the value of state function at initial stage and final stage will be same for cyclic processes. This is cyclic integration. This is called a cyclic integration of d phi. D phi means small change in state function. If you integrate those all small changes, you will get total change. Now the total change is 0 in the cyclic processes. Okay, then next. Now consider, let phi be a state function and if it is a function of x and y, where x and y are the two variables. What is the meaning of this theta? Phi is a function of x and y, means phi depends on some variables x and y. If it depends on x and y, then change in phi, or you can consider like this. Total change in phi will be taken as integral of dou phi by dou y, keeping x as constant into dy, plus integral of dou theta by dou x, dou x, keeping y as constant to dx. Now you will take differentiation. Now if an equation is given, okay, in that one variable is there, then differentiate or integrate with respect to that value. If you take the equation 7x plus 11, now they will tell differentiation differentiate this equation with respect to dx. How you will differentiate? You will take this x as variable, other as constant, and you will differentiate. Now here two variables are there. How to differentiate in this function, this condition? Okay, this dou means partial differentiation. Partial differentiation. What is the meaning of partial differentiation? If in a given equation, if two variables are there, then it is difficult to differentiate or integrate. At that time, for differentiation, we will use this partial differentiation. What is the meaning of that? Now, you have to differentiate a function which is, of a property which is the function of two variables. Then you have to keep one variable as constant. Here I have kept x as constant. Here it depends on x and y. No, I have kept x as constant and variation of phi with respect to y. Okay, variation of phi with respect to variation of y, that I have calculated, and then this is small variation. Now with respect to dy I have integrated. I have got full variation in phi with respect to y. Okay, I have got this one. Now dou theta by dou phi by dou x. What is the meaning of that? Then if now you keep y constant and you measure the variation of phi with respect to variation of x, that is partial differentiation. Okay, only the variation of phi with respect to x, you take that value, and now this is a small variation. Okay, now all such small values, all you have to integrate, you will get total change with respect to y. Total variation of phi with respect to x. Here you keep y constant, here you keep x constant. This whole will give total variation in phi. Okay. This is somewhat difficult for initiators now who are beginning to learn this thermodynamics. This equation is somewhat difficult, then also try to learn. Okay, if you want to copy down, you can note down, otherwise you can do. Okay, लिख लिया आपने. Now we will look into path function. Okay, what is path function? Path function means बिल्कुल उल्टा उसका स्टेट फंक्शंस का. क्या उसका वैल्यू, उसका वेरिएशन पाथ पे डिपेंड करता है. वो कैसे डिपेंड करता है आपको आगे आता है. ओके, पाथ फंक्शन means the function which depends on the path followed by the process. Example, heat and work. These two are heat transfer and work. These two are the main example for path function. Now I have said in first lecture only, thermodynamics, we will study about the flow of energy. Okay, here we will study about the flow of energy mainly in two forms. Here in thermodynamics, energy will flow mainly in two forms. One is heat, okay, another one is work. It will flow in the form of heat, or it will flow in the form of work. Now I will ask a question. Okay, it is based on last lecture. Okay, now take a container with insulated walls. Insulated walls means you have seen thermos flask. No matter, no energy can be exchanged. Okay, around that wall, and you place a piston here, movable piston. Okay, now here some gas is present. Okay, this system is example for which type of system? Open system or closed system or isolated system? मैं ऑप्शन दे देता हूँ आपको. ओपन सिस्टम, बी क्लोज सिस्टम, सी आइसोलेटेड सिस्टम, or D, none of this. Tell me the answer. It is example for, it is closed system. Okay, you cannot say that, and here also matter cannot exchange, energy cannot exchange, heat cannot exchange. So it is the example of isolated system. You cannot say like that, because if you movable piston, I said first only, if you press this piston, this gas will be compressed, means you will do work, means energy will be transferred in the form of work. I have said now only, energy will be transferred in the two forms, one is heat, another is work. Here the energy will be transferred in the form of work, so it is closed system. Okay, अब चाहे तो लिख लो. ओके, लिख लिया आपने. नेक्स्ट हम वापस टाइप्स ऑफ प्रोसेसेस पे आते हो. उधर रिवर्सिबल इरिवर्सिबल बेस्ड ऑन एग्जीक्यूशन, आई सेड नो, बेस्ड ऑन एग्जीक्यूशन process is classified into reversible and irreversible. Okay, what do you mean by reversible and irreversible? I will take an example, simple example, and I will make you understand what is reversible and what is irreversible. In the case of irreversible, you take a container. Okay, now place some movable piston on it. Okay, here some gas you take. Okay, now pressure from upside, how much will be there? Due to atmosphere, external pressure will be 1 atm. Okay, now place a block such that block exerts 9 atm pressure on it. Now the piston is at rest, means after clipping block also it is at rest. What is the meaning of that? Means if I am at rest, pressure from all sides are equal. Means now it is at rest, means pressure from downside and pressure from upside should be equal. For pressure from the upside, how much is there? 9 plus 1, 10 atm is there now. From downside also it should be 10 atm. Okay, now it is at rest. This is the initial state. Now remove this block. Okay, you remove this block. Now 9 atm is gone. Only 1 atm pressure is left from outside. Okay. Now the gas will expand. This lower pressure will be excess. No, the gas will expand. Up to how much time it will expand? Up to that state, up to which the lower pressure becomes 1 atm. Okay. If the lower pressure also becomes 1 atm, higher pressure also 1 atm, again it will be in rest. Means it will be a sudden process. If you remove block, it will go up suddenly and it will stop when the downside pressure will become 1 atm. Okay. This is a sudden process where only initial state and final state. Now think that it is expanded till here. Okay, here is the pressure 1 atm from downside. This is the final state. Only these two states are defined. The intermediate states are not defined. They are not in equilibrium. It is sudden process. You cannot define the intermediate stages. Now think that I am 5 floors upwards and I will jump from 5 floors. Okay. While jumping, you can define my state that I am alive, I am at rest. Okay. After falling down, you can state that I am dead. Okay. You can state my. You can guess my. You can what do you say? You can say about my final state. Okay, I am dead. You can say about my initial state. Okay, intermediate states you cannot say. Okay, now you don't tell that in intermediate states after falling you will die. In the intermediate states you are alive. So we in the irreversible process also we can define the intermediate states. Who can say that? While by seeing that height only, if heart attacks happens and if I die in intermediate stage only, okay, you cannot guess that intermediate states. That is called as irreversible process. Now what do you mean by reversible process? Okay. Now take the same example, piston. Pressure from atmosphere is 1 atm. Now don't place any block. You place some sand. Okay, sand like this, such that it exerts 9 atm pressure from outside. Now from upside 10 atm pressure is the total. From downside also it should be 10 atm. Now it will be in rest. Okay. Now you don't remove all sand suddenly you remove one particle. Now I have picked one particle, means 0.1 atm I have picked. Now it will become 8.9 atm. Now the total pressure becomes 9.9 atm. Now little bit the piston expands such that the gas expands such that the lower pressure also becomes 9.9 atm. Okay. Now this state is defined. Again you remove another sand particle. Again it will become 8.8. This will become 9.8. When this becomes 9.8, up to that it will expand again. Again you remove one particle, one after another. If you remove, it will expand slowly. Okay. Then the intermediate stages, final state and initial stage. These three types of stages are also defined here. Okay. This is called as reversible process. In reversible process, all the intermediate states are in equilibrium. But in irreversible state, only final state and initial state are in equilibrium. Okay. If you do you understand that? Okay. You can write, or otherwise you can take screenshot, or otherwise you can leave. Okay. Now in irreversible process, you saw that only initial and final states are in equilibrium. Here all states are in equilibrium with surrounding. Okay. Then here it is changing little bit slowly. Now means the force exerted on it by the pressure, down pressure, means the driving force is infinitely small. Okay. The driving force will be infinitesimally small. Here suddenly it has come, means the pressure will push the piston suddenly, means the force is larger. You can say, you define in physics that impulsive force, like that this force is also there. So this driving force is larger. Okay. Okay. Here dp, the small change in pressure, you can here you can define the small changes, all small changes, the integration of all changes give you the total change in pressure, or total change in state function. If you take example as pressure of state function, then the total change in that pressure will be small changes, the integration of all small changes from state 1 to state 2. If you consider initial state as state 1 and final state as state 2, it will be the change in pressure. Here change in pressure will be equal to pressure final minus pressure initial. Simple, no? If you want, you can write down, otherwise you can leave. Okay. Okay, now you have studied in states of matter the ideal gas equation, that is PV is equal to nRT. It is defined when the system is in equilibrium with surroundings. The whole process is in equilibrium. If it is at equilibrium, then you can use this equation for the condition for that state. Okay. Now here reversible state, all states are in equilibrium with the surroundings. So this PV is equal to nRT can be used for all intermediate stages. Okay. But here this ideal gas equation for ideal gas, PV is equal to nRT, can be used. only for initial state and final state. Okay, stage and final stage. Okay, now let's talk about graphs. If you take take the graph of any two state functions, let us assume PV graph, PV curve, pressure and volume curve. If you want to draw the PV curve, all the intermediate points you should know. If any system you take PV curve, now if you say that now the PV curve for this state is that system is like this, means what you are telling is here is the final state, here is the initial state, and each and every intermediate state you are defining. So this curve you are able to draw. Means all graphs can be drawn for reversible processes. For reversible process, all the intermediate stages you can note down now. So all graphs can be drawn for reversible processes. For irreversible process, if you take, then you know only initial state and final state. Intermediate states you don't know. It can be like this also, like this also, like this also, like this also. The graph. It may be however you want. You can draw. Means the graphs are not defined for this irreversible processes. Graphs cannot be drawn for irreversible processes. Okay, graphs cannot be drawn. What is the meaning of that? You can draw only graphs when the equations are given. Okay, now here what is the meaning of this? The equations can be given for reversible processes, but here equations cannot be given. That point also you add. Okay, equations can be given to this reversible processes. For this, equations can't be given. Okay. ओके लिख लो. ओके आप लिख लिया. ओके मैं अरेस्ट करता हूँ. Now we have discussed only reversible and irreversible processes with respect to system, not surroundings. Okay. Now I will give a note. This is a very important note. Okay. With respect to surroundings, all processes, चाहे reversible process or irreversible process, all processes are reversible. There is no any process in the world which is irreversible for surroundings, with respect to surroundings. How it is possible? Now you have said that the sudden change is there, so you have defined as irreversible process. Only final state and initial states are known for us. Okay, means the total change only has known. But with respect to surroundings, if you take what is surroundings in universe, you remove only system. Other all is surrounding. Okay, means surroundings is very big, such that if you take any process, any high process that is small to that, if you compare to surroundings, it is very small. Means that total change in that state function will be a small change. If you consider a big change or a total change of pressure for system, for surroundings it will be dp only. Means it will be small change in the pressure only. With respect to surroundings, it will always be small change. If you consider any processes, how many processes you want, you can consider. There will be small changes only for surroundings. What is the meaning of that? Means it will be the total pressure, total change you cannot define. If you want to define, you can integrate this. How much small pressure, small changes in pressure or small changes in state functions you can take. Means with respect to surroundings, every change is small. Small means what? Small changes will take place in only one process, not in irreversible process. It will take only in reversible process. Means with respect to surroundings, all processes are reversible. Okay. In based on this condition also, sometimes theory questions may arise. Okay, you note down better. Okay. लिख लिया आपने. चलो हम पांच फंक्शंस के बारे में बात करते हैं। दो ही पांच फंक्शंस है ना, हीट और वर्क, उसके बारे में बात करते हैं हम। ओके, पांच फंक्शंस। फर्स्ट वन इज वर्क, W. In work there are two types, okay? One is PV work, another one is non-PV work. Non-PV work means some electronic work or mechanical work, all we do no works, those are called as PV work. They are not discussed in thermodynamics. In thermodynamics we will only discuss about PV work. What is that PV work? We will discuss afterwards, okay? These are two types of work we will discuss. Okay, now sign convention. Sign convention, we will look into the sign convention in केमिस्ट्री। इन फिजिक्स उसका बिल्कुल उल्टा होगा, रिवर्स में होगा साइन कन्वेंशन। ओके, नाउ वर्क डन विल बी टेकन पॉजिटिव इफ इट इज डन बाय एक्सटर्नल एजेंट। वर्क डन बाय एक्सटर्नल एजेंट ऑन सिस्टम, वर्क डन ऑन सिस्टम बाय एक्सटर्नल एजेंट इज टेकन एज पॉजिटिव, एंड वर्क विल बी टेकन एज नेगेटिव if work is done by the system. If work is done by the system, then it is negative, and if work is done on the system, means it is done by the external agent, then it is considered as positive. Means compression, you can take that work during compression as positive, compression of gas, and during the expansion of gas you can take as negative. Okay, यही से आपका लेक्चर नंबर 2 थर्मोडायनेमिक्स पर खत्म होगा। वर्क के बारे में डिटेल में हम नेक्स्ट लेक्चर में बात करेंगे, और हम हीट ट्रांसफर भी देख लेंगे, और हम आगे चलेंगे एंट्रोपी, एंथैल्पी, इंटरनल एनर्जी, सब स्टेट फंक्शन को लेके हम आगे चलेंगे। ओके, थैंक यू स्टूडेंट्स।